Welcome everybody. So let's talk about page 4 of our week 4 concept check packet over ionic compounds. So now we've talked about the other things in the packet. Let's look at the formation of an ionic compound using Lewis dot symbols and think about how that relates to the things that we've been talking about. So we can go back to our very first thing that we talked about today and look at the number of dots here. And so we can see that each of these 3 X atoms has 2 dots, which of course means that it has 2 valence electrons. That also means, right, that X is in group 2A, and that of course reminds us that it's going to lose 2 electrons and form a 2 plus charge. So we can utilize the charge here in the symbol, but also the location on the periodic table. If we look at Y has 5 dots, so it has 5 valence electrons, and that of course means that it's in group 5A. And so remember that if it's in group 5A, it's going to gain 3 electrons. Notice it now has 8 dots. Again, we're trying to fulfill the octet rule. And so to form a -3 ion, it gains 3 electrons. And so this is what happens in an ionic compound, right? We have ions formed with charges, and that's because the electrons are transferred from the metal to the nonmetal. Right, we'll compare that when we get to our week 5 concept check when we talk about molecular compounds. And so we can take this generic ionic compound formation and we can make it specific, right? So when you look at barium here, what I want you to realize is that barium is in group 2A. And we're also looking here at phosphorus, which is in group 5A. And so we would expect barium to lose 2 electrons, and we would expect phosphorus to gain 3 electrons. Again, metals are going to lose electrons to empty out their valence shell. Nonmetals are going to gain electrons to put 8 into their current shell. And so think about what that means, right? Barium is going to become Ba2 plus. Phosphorus is going to become P3 minus. And so when we quote unquote cross the charges, we're going to get a formula of Ba3 P2. And so I just kind of want to draw your attention, right, to these coefficients up here, that we're going to get a 3:2 ratio. Again, because we're basically cross multiplying our charges to get a total charge that's equal for both positive and negative. So again, thank you for your time. At this point, please be working on the ionic compounds exercises.